So welcome everyone to the class on risk management and derivative subject, which is one of the most difficult subject for finance specialization student. And in that we are doing the chapter number 1, and the chapter is risk analysis on capital budgeting. Already we have discussed a lot about capital budgeting. Now we are only focusing on the risk parameters on capital budgeting. Yesterday I started solving problems on risk analysis or capital budgeting, where we did couple of problem on NPV where the probabilities are given to us. So we did a problem where possibly we had 1 year time period. In case if I give you a different time period like year 1, year 2, year 3, and then if I ask you calculate the NPV, if their initial investment is 10,000 rupees and the discounting rate is 10%, then calculate. So if you want to calculate under that scenario, so now same way whatever we have done possibly yesterday, like the same way. Here you have 3 different years. So here you have given the data of 3 different years. So if you get a data of 3 different years, not a big deal. So we can calculate the expected cash flow for each year. Okay, we can find the expected cash flow for each year. Discounting rate is 10%. We can easily discount it. We can easily discount it at 10%. Okay, we can easily discount it and we can find the NPV. That is not a big thing we can do. So if I ask you this expected cash flow for year 1, so the expected cash flow, expected cash flow, expected cash flow for year 1, for year 1, that would be how much? I hope this data is visible to you. That would be 2000 into 0.1, that would be 200. 4000 into 0.2, so that would be 800. So that will be 800, and then 6000 into zero point 0.3, that will be 1800. Okay, and then 8000 into zero point 0.4, that will be 3200. So for year 1, expected cash flow is 10, 18, 22 carry 5, 6, 6000. So you got the expected cash flow for year 1. Let me know if I make any mistake here. Similarly, I can find the expected cash flow for year 2. Similarly, I can find the expected cash flow for the year 2. So that will be 2000 into zero point 0.2, that will be 400. Okay, then 4000 to 0.3, that will be 1200. Okay, 4000 to 0.3, then 6000 to 0.4, that will be 2400, and 8000 to 0.1, that will be 800. So 00. So this would be 10, 18, 1 carry, then 2, 3, 4. Expected cash flow for year 2 is 4800. See that. Let me know if there's any calculation mistake, guys. You can use calculator, but I really suggest don't use calculator. But if you're not very much confident, you can use calculator, because in exam calculators allowed normal calculator. Expected cash flow for the year 3 you can find. Okay, that is 2000 to 0.3, that will be 600. 4000 to 0.4, that will be 1600. 6000 to 0.2, that will be 1200, and 8000 to 0.1, that will be 800. So I can find this. This is 10, 10 plus 12, 22, right? 6, 12, 14, 14 plus 8, 22, 2 carry 4200. So I got the expected cash flow for different years, first year, second year, and third year. So I got their expected cash flow. Once I got this expected cash flow, now I know the discounting rate is 10%, and I know the initial investment is 10,000 rupees. So I can find the NPV of the project. So NPV of the project is minus 10% plus what is your expected cash flow for year 1, divide by 1 plus WCC or discounting rate is given 10%, plus expected cash flow for year 2, divide by 1 plus 10% to the power 2. Second year, to the power 2 plus expected cash flow for the year 3, that would be 1 plus 10% to the year 3. So you can find the NPV of the project. NPV of project is minus 10,000 plus expected cash flow for year 1 is 6,000 divided by 1 plus 10% means 1.1. Second year, that is 4800 divided by 1.1 square plus 4200 divided by 1.1 cube. So you can find the NPV of the project. So the NPV of project is minus 10,000 plus. So you can find the present value of this. This would be six. This would be 6,000. This will be 6,000 divided by 1.1 plus 4,800 divided by 1.21 plus 4,200 divided by 1.331 if I'm not wrong. So you can find the present value of this. So you can find the present value of this. All these values you can use calculator, find the present value. So first one is 6,000 by 1.1, 6,000 by 1.1, that is 5454.54454. This is minus 10,000 plus 5454.54, that will be recurring decimal. Okay, then 5454, then 4,800, then it is 4,800 divided by 1.21. That is 3966.942. 3966.942. Okay. Then third one is 4200 divided by 1.1 cube. So that is 3155.522. That is 3155.522. So you can solve this. So with this, you can find your NPV. So with this, NPV of this project will be 10 minus 10,000 plus do the sum of this. If I do the sum of this, I will get 12,577.01. So you can find the NPV of the project, that is 2,577.0. So that is the NPV of the project. Let me know if anyone have any doubt. If anyone have any doubt, please ask me. Very good, Devika. So any step you want me to revise, anything you want me to concentrate again, let me know. So in this question, what we have done, for different years, probability was given with respect to each cash flow. So I determined the expected cash flow. I determined the expected cash flow for the different years because I want to know the feasibility of this project, and the project will be feasible only when the NPV is positive. So in order to do that, what I did, the cash flows, what I get, the expected cash flows, what I get for different years, I determined the present value of those cash flows. And once I got the present value of those cash flows, I subtracted that the sum total of that present value with the initial investment, and the value what I get is the NPV of the project. Anyone, any doubt, any question? Okay, fine. Then I'll go ahead. So here we discussed the calculation of NPV and expected cash flow till now. So we are going step by step. I hope you are understanding. Then the next thing we need to study is the concept of variance. So things are not like the way we expect in our life. So expected cash flow, or the average return, whatever we talk about, that is the best case scenario. That is a general scenario. So we expecting that will generate these cash flows. But there's always there's always the chance is there. There's always the chance or risk is there that we may get not what we expecting. So that time we talk everything in the term of risk. So the statistical tool what we use to measure the risk that we called as variance, or we talk in the term of standard deviation. So when we say variance, variance is the square of standard deviation. So when I say variance, variance is the square of standard deviation. So variance is the square of standard deviation. Okay, so you can remember this. So the on the term of historical data, when we calculate the variance, you remember, I think you can remember in statistics in first semester, we studied all this. So there when we are talking about variance, so the formula of variance, if you have raw data, then the formula is sum of x square by n minus x bar square when you have raw data, or we calculate the variance by the formula called sum of x minus x bar whole square by n. This was the formula, variance formula. Square root, if you do of this, you will get a standard deviation. So when you have raw data, so when you have raw data, so if you have a data of where you have class interval with frequency, if I talk about variance calculation, when we have class interval with frequency, if you have class interval with frequency, so how will you calculate the variance? How will you calculate the variance when you have class interval with frequency? The formula of variance is summation of f x minus x bar whole square by summation of f. This is one formula. Another formula is summation of fx square by summation of f minus summation of fx by summation of f whole square. So this is another formula when you have class interval with frequency. So we talk in the term of variance. Okay, we talked in the term of variance. So variance is a parameter which help us to measure the risk. Okay, on any form of investment source or any form of data. Okay, so the risk what each data is having, that we call as variance. So variance is the risk on a individual, variance is the risk on an individual asset or individual avenue, anything you can say, that is called variance. If you bring more than two avenues together, then you'll have form of risk which we call as covariance. So I hope you remember, I have taught you in statistics the same thing you study in portfolio management also. So when you bring more than two variables together, then you have new kinds of risk which we call as covariance. Suppose two variables are x and y. So what is a covariance between x and y? That will depend on the coefficient of correlation between x and y into standard deviation of x into standard deviation of y. So this is the formula. It is very important for you when you study portfolio management, when you study statistics, the relation between risk, covariance. So when you're bringing more than two variables together, then you have new kind of risk which we call as covariance. Okay, so here till now whatever I have told you, or just till now whatever I was talking, we were talking about the concept which we already know, which we already studied in our previous semester. Okay, right now I'll talk about when data is given in probability, when data is given in probability, when data is given in the term of probability, in the term of probability, when you have data in the term of probability, okay, then then your variance your variance is basically the follow the formula sum of pi into xi means individual value minus your expected value. What is expected value? Whole square. If you do the square root of this, you'll get standard deviation, where your expected value is nothing but sum of probability into your individual value. So that will give you the formula of variance. So remember this. So we'll do calculation to make you understand this concept. Kishore is asking how to calculate the probability. Probability you cannot calculate, Kishore. Probability we put depending upon the chance that how that event can happen. How to calculate the probability, if you want to know, for that I need to teach you mathematics, where I need to teach you a topic called probability. Then we'll need to discuss random experiment, binomial theorem, all that. So we need an around 10 to 15 hour time to understand the concept of probability. What is random experiment? What is odd in favor? What is odd against favor? Then how we can work on random experiment, what is binomial trials, binomial theorem concept, NCR, P to the power R, U to the power N minus R. So ultimately, when we talk about probability, there's altogether a different tool you require to calculate the probability, or you can put probability values depending upon the likeliness of that outcome, how much chance that that outcome can happen. So always there's a chance that what you expecting at this time, what you expecting, are you expecting worst case scenario right now, or you're expecting good case scenario, or most likely scenario, or best case scenario. So definitely at this scenario, this time what we are suffering right now because of Chinese coronavirus. So at this scenario, automatically everything you'll put under worst case data. So everything is right now become critical thing. All form of risk analysis, if you do at this scenario, everything you will do on the critical scenario. You will not consider best case scenario. The probability, if you put for the best case scenario, that you will put very less, because it is not logical right now to consider the 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 probability scenario at this extent. So ultimately, it all depends on how you look into the impact, how that scenario is building around us, and that can be based. The probability can either based on your intuition, or it can be based on purely on mathematical tools. We have lot of softwares who can work on algorithm, and they can tell us the values what we can consider right now. So I hope you are getting the concept. So now coming back to the question. So this is the formula which I just now told you. This is the formula what we'll use now for calculating the variance. We'll not use that formula. The formula which I told you, that those formulas were earlier formulas were basically based on historical data. All these formulas were basically based on historical data. So we'll not use it right now. We'll only focus on this formula. Okay. In exam also, you get a numerical based on this formula only. If you see your previous year questions, risk management, previous year questions, if I open, if you see, you get a problem based on this formula only. So you can see this question number from Shivam Limited is considering two mutually exclusive projects A and B. Project A cost 36,000, B cost 30,000. You have been given the net present value probability distribution of each project. This much is given. Compute the expected net present value of project A and project B. So how will you calculate the expected net present value? By simply multiplying and doing the sum. So then compute the risk attached to each project, standard deviation. So how will you calculate the standard deviation? So I told you the formula. This is the formula. This is the formula of variance. You do the square root, you will get the standard deviation. Then which project will you recommend? So which project will you recommend? For that, to decide which project should we go with, whenever we have decision making scenario, whenever we have decision making scenario, okay, whenever we have decision making scenario, then we'll decide decision making scenario based on coefficient of variation. We decide based on coefficient of variation, where coefficient of variation, the formula is standard deviation by mean into 100. So I will find the coefficient of variation of both the project. Okay, we'll find the coefficient of variation of both the project, and then based on the data what we get on the coefficient of variation, we'll decide which project to accept or which project to reject. So all that we'll do. So before that, do one simple problem based on the concept of variance. Suppose this is the question. Okay. So this is the question. You can see the two projects are there, A and B. Okay, and you want to calculate the variance and standard deviation of both the projects. Okay, so then let me do this problem for you people. So I'll write down the complete data. Okay, so event. So you have 5 event A, then you have B, and you have C, and you have 5 event. Okay, cash flows, probability, event A. So that is 0.10, 0.20, then 0.40, 0.40, then 0.20, then 0.10. Probability is given. Yeah, here we are calculating, Kishore, we are calculating variance and standard deviation, Kishore. I hope you are understanding. Yesterday, if you have done, I think if that is the same problem, then we calculated the expected cash flow yesterday. And today we'll go beyond the expected cash flow. Today we'll calculate the variance and standard deviation. I hope you are understanding. 8,000, 10,000, 12,000, then 14,000, and then 16,000. So these are the cash flows. So what I can do, I can find their expected cash flow. I can find the expected cash flow. So that this would be 800. This would be 2,000. Let me know if I do mistake anywhere. So this would be 4800. This will be 4800. This will be 2800, 2800, and then this will be 1600. So the expected cash flow will be the sum of this. Expected cash flow, do the sum, put two zeros, then 8 plus 8, 16, 16 plus 8, 24, 24 plus 6, 33 carry. So 3 carry 3 plus 2, 5, 5 plus 4, 9, 9 plus 1, 10, 10 plus 2, 12, 12,000. Expected cash flow is 12,000. Yesterday, the problem what we did, did we get 12,000? That I'm not sure. Maybe we got, I have no idea. So the expected cash flow is 12,000. Let me know if there's any calculation mistake, guys. Let me know if there's any calculation mistake. So once you get the expected cash flow, guys, once you get the expected cash flow, so once you're done and you get the expected cash flow, this you have to find expected cash flow. Once you got the expected cash flow, now what you will do, find the difference. Suppose this cash flow, suppose this cash flow, I am writing a symbol xi. Okay, so suppose the cash flow means xi, so I'll find xi minus exi. I hope you're understanding. So expected cash flow, I'm using a symbol for that. That is EXI. This means the expected cash flow. I hope you don't mind me putting that symbol. So you got the values. You got the values. You got their values. So find XI minus EXI, 8,000 minus 12,000. So find that difference. So that will be what? Minus 4,000. Okay, 10,000 minus 12,000 will be minus 2,000. 12,000 minus 12,000 is 12, 0. 14,000 will be 2,000. 16,000 will be 4,000. Anyone, any doubt? No need to do the sum of this. No need to do the sum of this. Sum of this, if you do, you will get 0 only. Sum of this, if you do, you will get 0 only. No need to do this. I hope everyone is understanding. This is what we are doing here. If you observe the formula, if you observe formula here, the formula, if you see the formula here, with the formula you can understand. So I have found this value. I found this value, net cash flow minus expected net cash flow. So that is what. So net cash flow minus expected net cash flow. That is what I'm trying to do. So once you get this, once you get this, once you get this value, once you get this value, do the square of this. Do the square of this xi minus xi. The value what you get. Do the square of this. Do the square of this. Okay, do the square of this. This is 16, and then 3 zeros there becomes 6 0. 1, 2, 3, 4, 5, 6. Then this is 4 and then 6 0. 6 0. Then you can write 6 zeros. Then this is 0. Then again 4 and then 6 zeros. And this is then 6 zeros. Once you get this value, now multiply probability with this. Multiply probability with this xi minus I multiply probability with this. So 16 into 10 to the power 6 into 0.1. So 16 into 10 to the power 6 into 0.1 means 16 and then 5 zeros. Then 5 zeros. Then 4 into 10 to the power 6 into 0.2. So 4 into 0.2, 4 into 10% or 20%, you want 20% of this. 10% of this would be 4 into 10 to the power 5, and 20% would be 8 and 10 to the power 5. So 5 zeros, this would be, then uh, this is 0.2 only, no? 0.2 into the same thing, you'll get the same value. 8 and 5 zeros, then 16 and 0.1. Same data is probability. So you will get 16 and 5 zeros. So the sum total of this sum of EI into xi minus EXI, the whole square, that is your variance. So 16 plus 8 is 24. 24 plus 24 is 48. 48 and then 5 zeros. So the standard deviation, this is the variance. This is the variance. This is the variance. If you want the standard deviation, if you want the standard deviation is the square root of this. Standard deviation is the square root of this, which we call sigma. That is the square root of this. 48 and then 5 zeros. Find the square root of this. Find the square root of this. 2190.89. 2190.89. So you got the standard deviation. Clear? Anyone have any doubt? Please ask me. Any step, anyone have any doubt? Please ask me. Anyone, any doubt? Now let's discuss the calculation of variance and standard deviation for the project B. And I believe you know that very well, that variance is the square of standard deviation. So just simply copy this data. So I'll go down. So if you have not written, I really request everyone, please copy this data and write the data for project B, because now we have to do a separate calculation for project B. So quickly everyone, or you can pause anytime to write down the data. So now I'll go down. I'll write the for project B. So calculation of standard deviation for project B. So calculation of standard deviation. The same thing you'll study in portfolio management also. Similar kind of problems you'll see there also. Calculation of standard deviation. Only thing here, we'll do all our calculation on topics like NPV, okay, cash flows. There you'll do data, you'll do calculation on return. So that difference only comes. So variable may change, but logic remain the same. Calculation of standard deviation. Calculation of standard deviation of project B. We are doing here on project basis, project analysis and implementation we are trying to do. So we have different events. We have different events. Events, you have 5 events, I believe. Event A, B, C, D, E. So I hope you people are understanding. Anyone have any doubt, please feel to ask your problem. For you only, I'm writing and I'm doing. I would have done directly in MS Excel. Everything in MS Excel, it would have been like, it would have been minute work to me. So the purpose why I'm writing this, not doing in Excel, because if I do in Excel, you may feel disconnected. So that's why I'm not writing in Excel, so that I can connect you people. The reason of doing this is to make sure that you feel connected, because you are doing on pen pencil. So if I also do on pen pencil, that way we can feel connected. That is my logic. I hope you'll agree with me. So project B, the probability is 0.1, 0.15. Okay, then you have 0.5, then you have 0.15, and then you have 0.10. Let me know if you need any help in IFM or portfolio management, anything. I can make a separate video for those things. So cash flows are 24,000, then you have 20,000, then you have 16,000, then you have 12,000, and then you have 8,000. You have cash flows, you have probability. Now what I can do, I can find the expected cash flow. I can find the expected cash flows. I can find the expected cash flow. So 24,000 to 0.1 is 2400. 20,000 into 0.3, that will be 3,000. Correct me if I'm wrong. Okay, 16,000 to 0.5 will be 8,000. Then 12,000 to 0.15 will be 1,800. 8,000 to 0.1, that will be 800. So you can find the expected cash flow for project B. Expected cash flow, this I'm writing with EXI, please don't mind. So expected cash flow for project B. So that is, now you do the sum of 8 plus 8, 16, 16 plus 4, 20. So 22, 2 carry, then 2 plus 2, 4, 4 plus 3, 7, 7 plus 1, 8, 8 plus 8, 16. So you'll get the expected cash flow here at 16,000. Okay, so you get here expected cash flow as 16,000. So these cash flows, I hope you don't mind. I'm using a symbol called XI for that. So I got their expected cash flow. So once I get the expected cash flow, so I can find the difference between the cash flows and expected cash flow. So difference between XI minus EXI. No need to do the sum of this, because the sum of this will be zero only. The difference in the sum, that is a property of average. So XI xi, what are the individual? 24,000 minus 16,000, that will be 8,000. Then next one, 20,000 minus 16,000, that will be 4,000. Then then 16 minus 16, that will be 0. Okay. Then 12 minus 16 minus 4,000. 8 minus 16 minus 8,000. So we got this value. Now again, what you will do, you will do the square of this. So xi minus exi, you will do the square of this. 8 square 64 and then 6 zeros, and then 6 0. 4 square 16 and then 6 zeros. Then 4 square is 16 and then 6 zeros. And 8 square 64 and then 6 zeros. Okay, you will get the square value. Okay, then you multiply with probability minus exi. So probability is 0.1 into 64 into 10 to the power 4 means 64 and 5 zeros. Then 16,000 and 0.15. So 16 into 15 कितना होता है? 15 into 16 is 240 I guess. 15 square 225 plus 15, it is 15 into 10 to the power 16 into 10 to the power 6. 10 to the power 6. This is 15 into 10 to the power minus 2. 0.15. This is 240 into 10 to the power 4. Means 24 into 10 to the power 5. 24 into 50. 24 and then 5 zeros. Correct me if I'm wrong. Then next one would be 0. Then 16, same probabilities. Same is written. You can see same 0.15, 0.1, 0.15, 0.15, same data you'll get. 0.15, 0.1. Can do the sum of this, sum of probability already you multiply, sum of ei into xi minus ei. This is the variance. This is the variance, and this is equal to how much? 24 plus 64 is 88. 88 twos 88 twos I think will be 176. 90 twos will is 180. And yeah, 176. 176. 176. 88 twos 16 and 176. So this is 176, then 5 zeros. So the standard deviation of this, standard deviation would be nothing but a square root of this, square root of variance, that is 176, then 5 zeros. Find the square root of this. Find the square root of this. 4195,235. 4195, 4195,235. 235. Fine. This would be the standard deviation. So we found the standard deviation of project A. We found the standard deviation of project B. Anyone, any doubt, anything you want me to discuss, any part you did not understood? Anyone, any question, anything you want to ask from me? If no one have any doubt, then I'll wind up the class. Please ask me if you have anything. Anyone, any doubt? So, so normally whenever we have to do judgment, imagine I have project A, project B, I have to make a judgment that which project can I do. Like, so if you see project A, project B, 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 okay, if you see project A, project B, the expected return, the expected return on project A is how much? The expected return on project A was 12,000. The expected return on project A is 12,000. The expected return on project B is 16,000. So if you look into expected return, remember yesterday we were doing on expected return only, no? Sorry, expected return is not the right word. Expected cash flow, right? Those data are cash flow or NPV. These data are cash flow or NPV cash flow. So this is expected cash flow. So your expected cash flow, these are your expected cash flows. So these are your expected cash flows. So if you do judgment based on the expected cash flow, you can see project B is better. But you need to understand, you cannot simply rely on the expected value. You need to understand to get that expected value, how much is the risk you are having. So this I'm using a symbol called EXI, that is expected cash flow. Then what I did, I calculated the risk. And how we calculated the risk? By finding the standard deviation. So if I look into the standard deviation, project A standard deviation was how much? 2190.89. Project A, what happened? Project A standard deviation was 2190.89. Project A standard deviation was 2190.89. Project B standard deviation was 4195235. 4195235. Now, guys, if you see the standard deviation, project B standard deviation is is near to double of project A standard deviation. But the return of project B is not double of return of project A. So the best way, whenever you have to make a judgment, the best way to decide, find the coefficient of variation. Find the coefficient of variation. Coefficient of variation of project A, that is standard deviation by me, that is 12,000 into 100. If you want in percentage, this would be standard deviation 4195, 4195.235 divide by mean is 16,000 into 100. So whichever project we give you the lesser coefficient of variation, you will consider that project. You will go with that project. Okay, always whenever you have to make judgment, you make judgment based on coefficient of variation. Okay, so whenever you have to make a judgment, you always judge the project based on the coefficient of variation. This is 219089. Okay, divide by 12,000, divide by 12,000, you will get 18.2574. 18.2574. This project coefficient of variation, that will be 419523.5 divided by 16,000. So that will be 26.220218. So if you look into the coefficient of variation, if you look into the coefficient of variation data, if you look into the coefficient of variation data, you can directly say that project A is better, because if you see project A and project B, the how much project B return is more than project A. So that is 4 by 12. 4 by 12 is 1 by 3. It is return is 33.33% more. It return project B return is 33.33% more. Okay, the return, or better you can understand, the cash flow of project B is 33.33% more, but how much is risk is more? How much is risk is more? 4195.235 minus 2190.89 divided by 2190.89 into 100. If you do that risk calculation, if you do the risk calculation, so this minus this divide by this, so if you 91.48. So if you see the risk is 91% more. It's like double, near about double. Return of project B is only 33.33% more, but the risk is 91% more. So you can use your judgment to get 33.33% more cash flow. You have to take 91% more risk. Definitely, you will not consider that scenario. So if you see this, which project, if you see the coefficient of variation, if you see the coefficient of variation, the coefficient of variation of project B is more than the project A. So whichever cash flow, whichever project is giving you lesser coefficient of variation, you should prefer the project. Project A should be preferred. Project A should be preferred over project B. Over project B, because when we consider the coefficient of variation, we take into consideration both the parameter, risk also, return also. I hope you people understood this. Anyone have any doubt? Please ask me. If no one have any doubt, then I'd like to wind up the class. If anyone have any doubt, please ask me. So it's time to wind up the class. Thank you, everyone. See you all in next class. Till then, be very safe and take care of yourself and your family. And I'll see you all in next class. Take care, everyone.